Hey there everyone, welcome back to reading passage 2 for the test number 3. For this video we're going to be talking about something related to biology, if I'm not mistaken. Autumn leaf. So we have some sort of matching features. So we have some sentence completion with one word only. There we go, we have one word only, and we have true false not given, and finally we have some sort of a title, choosing a title. What is the most suitable title for this passage, and blah blah blah. However, the question is kind of a little bit, they have altered it a little bit, saying that following question, does the writer offer an explanation? So like it means like what is this whole explanation is going to be about. So yeah, let's see that, and we'll go one by one. So in terms of, let me try to explain. So when it comes to doing what is that called, matching features, I guess. It's like whenever you're doing a matching feature, you have to keep an eye on these kinds of questions and questions for true false not given as well. However, because I believe that we have 1 2 3 4 5 6 7 8 and 9 paragraphs, there's a very low chance that the chances are very few that we will find any of these questions. I mean, not this one necessarily, but chances are low because that these questions are going to be answered. However, we'll try to find as fast as possible. So yeah, let's begin. I'm gonna try to zoom in a tiny bit. So there we go. All right. Canadian writer J. Ingram investigates the mystery of why leaves turn red in the fall. Okay, so fall, we have that. Why leaves turn red in the fall, and we will find that out now. One of the most captivating natural events of the year in many areas throughout North America is turning of the leaves in the fall. The colors are magnificent. So one thing I want to mention is that while I'm reading all the whole passage, like paragraphs, it is also essential to highlight for yourself or to take into your notes that you might find very interesting expressions you may use in your IELTS speaking as well as writing. For example, the word like the colors are magnificent. You can obviously use this answer as what is the weather like in your country. You may say that the weather is maybe hot, maybe like warm climate, it may be cold climate, and then and if the question is like, what is your favorite weather, you can say like it's autumn, because the leaves, while the leaves fall, the colors are magnificent of the leaves are red, blah blah blah. So yeah, let's keep reading. Anyway, but the question of exactly why some trees turn yellow or orange and other are red or purple is something which has long puzzled scientists. Okay, this is the description of substance responsible for the red coloration. This is number 1. The reason why trees drop their leaves in autumn. Okay, so why trees drop their leaves exactly that season. Some evidence to confirm a theory about the purposes of the red leaves. Okay, an explanation of the function of chlorophyll. We have that as well. A suggestion that the red coloration in leaves could serve as a warning signal. Okay. Right. So summer leaves are green because they are full of chlorophyll. So okay, summer leaves are green because they are full of chlorophyll, the molecule that captures the sunlight and converts that energy into new building materials of the tree. All right, there we go. We have I guess we have the first answer. I guess we have two. We have to find out whether or not we're right. The reason why trees, where was the chlorophyll? An explanation of the function of chlorophyll. So what does the chlorophyll do? It's a molecule that captures sunlight and converts the energy into new building materials for the tree. As fall approaches in the northern hemisphere, the amount of solar energy available declines considerably. So you have another expression you can use in task 1. So I'm just gonna underline these as in cyan color. For many trees, evergreen conifers being an exception, the best strategy is to abandon photosynthesis until the spring. So the word evergreen is a really nice one here, but the word evergreen has 2 definitions. The first one is trees full of green leaves throughout the year. For example, you can say an evergreen autumn. However, the second definition is like, it means always popular. You can say that the celebrity performed her or his evergreen concert and something like that. So rather than maintaining the now redundant leaves throughout the winter, the tree saves its precious resources and discards them. But before letting its leaves go, the tree dismantles the chlorophyll molecules and ships their valuable nitrogen back into the twigs. As chlorophyll is depleted, alright, there we go. Let me just choose a different color. Other colors that have been dominated by it throughout the summer begin to be revealed. This unmasking explains the autumn colors of yellow and orange, but not the brilliant reds and purples of trees such as the maple or sumac. So I think that the function of chlorophyll is already explained in paragraph B. Let me remove that because the function of it means what does exactly chlorophyll do? It's a molecule that converts energy that is taken from the sunlight into the tree. This is the basic explanation. However, we also can find that the reason why maybe we can find another answer for this, maybe like for like 15, I guess. The reason why trees drop their leaves in autumn, right? So because it says that as fall approaches in the northern hemisphere, the amount of solar energy available declines considerably. So for many trees, evergreen conifers being an exception, the best strategy is to abandon photosynthesis until the spring. So that's why that is the reason why it falls exactly in autumn. So we just want to choose B as well, because you also have to make sure that we have this as an option. You may use any letter more than once. This is just like I just made it a red color, so like it's like a warning signal. Now substance responsible. Alright, we will read paragraph C. The source of the red is widely known. Alright, so the widely known red coloration. I want to take that. It is created by anthocyanins, so cyanins, I guess, water soluble plant pigments reflecting the red to blue range of the visible spectrum. They belong to a class of sugar-based chemical compounds also known as flavonoids. So the word also known as is like it's a technical, something that is mostly referred to technical terms, but not always. What's puzzling is that what is very confusing is that anthocyanins are actually newly minted, made in the leaves at the same time as the tree is preparing to drop them. I guess that's the description of substance responsible for the little red coloration. So yeah, it's source of the red is widely known. It is created by anthocyanins, a water-soluble plant pigments reflecting the red to blue range of the visible spectrum. They belong to a class of sugar-based chemical compounds also known as flavonoids. So, and it's also saying that what is puzzling is that it's actually newly minted, made in the leaves at the same time as the tree is preparing to drop them. But it is hard to make sense of the manufacture of anthocyanins. Why should a tree bother making new chemicals in its leaves when it's already scrambling to withdraw and preserve the new ones already there? So yeah, we have the answer for as an option C. I'm gonna take that. Alright, we have two more. Now let's read the paragraph D. Some theories about anthocyanins have argued that they might act as a chemical defense against so anthocyanins, they act as a chemical defense against by insects or fungi, I mean, or that they might attract fruit-eating birds or increases the leaf's tolerance to freezing. However, there are problems with each of these theories, including the fact that leaves are red for such a relatively short period that the expense of energy needed to manufacture the anthocyanins would outweigh any antifungal or anti-herbivore activity achieved. So there we go. We didn't necessarily find the answer for that yet, but do we have anything here? We don't have an evidence of any theory, but also we don't have the warning signals. Let's just read a little bit more. It has also been proposed. Okay, we have it has also been proposed. Is some sort of a suggestion. It has also been proposed that the trees may produce vivid colors to convince herbivorous insects that they are healthy and robust and would be easily able to mount chemical defenses against infestation. So there we go. So we have the answer. A suggestion that red colors in leaves could serve as a signal. Warning signal. A warning signal for the herbivorous insects that is that when they look at the tree, they see that it's healthy and robust and would be easily able to mount chemical defenses against infestation. So if insects paid attention to such advertisements, they would they might be prompted to lay their eggs on a duller and presumably less resistant host. The flaw of these theories lies in the lack of proof to support it. So yeah, there we go. We have another some sort of an explanation as well. So let me remove that underline. So yeah, we're gonna, it is paragraph E, I guess. Now there we go. I really believe that I'm doing it correctly. Some evidence to confirm a theory by the purpose of the red leaves. Okay, now purpose of the red leaves. Now do we have paragraph, what do we have in the paragraph F? Okay, we have perhaps the most plausible suggestion as to why leaves would go to trouble of making anthocyanins when they're busy packing up for the winter is the theory known as the light screen hypothesis. Okay, we have that light screen hypothesis. Make sure, because we are also we also want to find the answers for these as well. But however, I'm not going to be answering them just yet. I want to go one after another. So it sounds paradoxical, meaning very confusing, because the idea behind this hypothesis is that the red pigment is made in autumn leaves to protect chlorophyll, so the light absorbing chemical, from too much light. Why does chlorophyll need protection when it is the natural world's supreme light absorber? Why protect chlorophyll at a time when the tree is breaking it down to salvage as much of it as possible? Okay, we don't have nothing about that yet, just yet. All right, some evidence to confirm a theory about the purpose of the red leaves. What is the purpose of the red leaves, honestly? Okay. All right. Chlorophyll, although acquisitively evolved to capture the energy of sunlight, can sometimes be overwhelmed by it, especially in situations of drought, low temperatures, or nutrient deficiency. Okay, we want to underline that as well. Moreover, the problem of oversensitivity to light is even more acute in the fall, when the leaf is busy preparing for winter by dismantling its internal machinery. The energy absorbed by the chlorophyll molecules of the unstable autumn leaf is not immediately channeled into useful products and processes, as it would be in an intact summer leaf. The weakened fall leaf then becomes vulnerable to the highly destructive effects of the oxygen created by the excited chlorophyll molecules. Okay, reconfirmation. No, we don't have anything just yet. Even if you had never suspected that this is what was going on, or when the leaves turn red, there are clues out there. Okay, finally we have a word saying clues, meaning an evidence. Okay, to confirm the theory about the purposes of the red leaves. One is straightforward. On many trees, the leaves that are the reddest are those on the side of the tree which get most of the sun. So I think this is the answer, is it? Yeah. Meaning, if you have never suspected that this is what was going on when leaves turn red, there are clues out there. One is straightforward. That is saying. So basically, so this is the first one. Not only that, meaning this is the second, but the red is brighter on the upper side of the leaf. It has also been recognized for decades that the best conditions for intense red colors are dry, sunny days and cool nights. All right. Yeah, we're gonna. So that's basically paragraph H. We don't really have to think more about that, because the purposes of the red is, first of all, the writer is saying, even if you had never suspected that this is what was going on when leaves turned red, there are clues out there, there are evidence out there. So, and then the writer is providing 3 different clues explaining why leaves turn red, right? So there we go. Now we have the sentence completion. We want the sentence completion, and it's one word only. The most vividly colored red leaves are found on the side of the tree facing the. Okay, we have one is straight from on many trees. The leaves that are the reddest are those on the side of the tree which gets most sun. On the side, so the vividly colored red leaves on the side of facing the sun. So there we go. We have the sun there. Alright, the something surfaces of leaves contain the most red pigment. Not only that, but the red is brighter on the upper side upper side of the leaf. Surface is the side, so the upper side is the answer for yours. Red leaves are most abundant when daytime weather conditions are something and sunny. Okay, there we go. We have this one as an answer, and it's referring to saying surface. So the red leaves are the most abundant when daytime weather conditions are something. So daytime are something and sunny. So decades that the best conditions of intense red colors are dry and sunny days and cool nights. So we have cool nights. This cool nights meaning it's a cold weather at night, and at the daytime it's sunny and dry. So meaning it's dry. It's not cool. So it's exactly referring to daytime. However, cool is at nighttime. So we don't choose the word cool. We choose the word dry. The intensity of the red color of leaves increases as you go further. So conditions that nicely match those that make leaves susceptible to excess light. And finally, trees such as maples usually get much redder the more north you travel in the northern hemisphere. So the more north, so as you go further, as you usually get much redder the more north you travel. So the more north you travel, so the answer is north. Okay, so it's north. Okay, so we got that. It is likely that the red pigments help to protect the leaf from freezing temperatures. Okay, so was it freezing temperatures? And I guess no. It sounds paradoxical. Red pigment is made in autumn leaves to protect chlorophyll, not from the freezing temperatures. It's a false. There we go. The light screen hypothesis would initially seem to contradict what is known about chlorophyll. And I obviously think that that is somehow true, because it sounds paradoxical, and then the writer is giving the questions. Why does chlorophyll need protection, and why protect chlorophyll at the same time when it's a supreme light absorber? So yeah, it's going to be true for us. Okay, whoops, sorry for that. I have to put true over here. Leaves which turn colors other than red are more likely to be damaged by sunlight. There was nothing about harming the light. I mean, sorry for that. Harming the plant when used for the sunlight. But however, this what is not fully understood, however, is why some trees resort to producing red pigments while others don't bother, and simply reveal their orange or yellow hues. Do these trees have other means at their disposal to prevent overexposure to light in autumn? Their story, though, is not as spectacular to the eye, will surely turn out to be as subtle and as complex. Okay, so this number we're not going to deal so much. The answer is not given for that. And finally, we have for which of the following questions does the writer offer an explanation? Why conifers remain green in winter? So let's see that. I remember the conifer was conifer. We have conifers being an exception. The best strategy is to abandon photosynthesis into the spring. So rather than maintaining, they're now redundant. So there is it's not saying why conifers remain in the winter. So this option is removed, and I'm gonna put red there. How leaves turn orange and yellow in autumn? I like this option. I'm gonna make this. I'm gonna take this for myself right now. How herbivores insects choose which trees to lay their eggs on? But yes, we do have some particular portion of it. It says that herbivores insects that they are healthy and robust and would be easily able to mount chemical defenses against infestation. If insects paid attention to such advertisements, they might be prompted to lay their eggs on a duller and presumably less resistant host. I like this option as well, but not really though. However, because it's kind of the because however it says that no one has yet ascertained whether more robust trees support the brightest leaf or whether insects make choices according to color intensity. So yeah, it's not true. So I think that is another red sign for us. Why anthocyanins are restricted to certain trees? And I'm 100% sure that this option was not given as well. So I'm gonna remain with paragraph. With the option B. So there you go, guys. We basically finished passage number 2 as well. It was as fast as possible and the easiest of them all. So yeah, if you have any questions, please do not hesitate to leave your questions in the comment section below. I'll try my best to answer those questions. And yeah, if you like the video, of course, smash that like button. If you dislike it, you might smash the dislike button as well. However, thank you very much for watching and have a wonderful time ahead.